Okay, let's continue with the last example we did about postcondition. This one is actually particularly interesting. You might run into this for maybe either projects or future labs. So let's do it properly. Okay, again, let's just do it from scratch. We're talking about this particular query here. We're taking an input array of integer, just make it simple. We're just going to return another array, which means result, in this case, is of type array of integer. For example, if you got this particular array, over here, let's say it's simply, let's say 3 minus 1, 2 minus 4, and then 5, for example. Let's say you got an array of size 1, 2, 3, 4, 5, 5 elements inside. And now, what do we expect to see in the result? Well, it should be just another array result, and all the positive numbers should be there. So that means we got 3, and then 2, and then 5. So that's kind of like one example for input and output, right? That's what we said. Now, we want to look at the contracts. That's really what we focus on, right? The implementation will be rather trivial. However, we want to do the postcondition in such a way that any evil supplier doing wrong implementation can be caught as a contract violation at the runtime. That's how we judge to see whether your postcondition is good or bad, right? Let me just recap what we did last time. The current postcondition over here is attempting something good, but it's not complete, because you're only trying to assert everything in the result is simply just a positive number, right? That's not good enough, because you can simply say, let's say result is simply, let's say all positive, it can be very big, and then you can just get 4, 1, 6, 7, 8, and 9. None of them actually belongs to the original array, so that's not right. I tell you what, to be even simpler, the result can just be an empty array, right? Remember we said before, universal quantification on an empty array is just going to be true. So now, if the supplier over here simply give you an empty array always, it's always going to pass this universal quantification. Okay, are we okay with this? Okay, that's something to keep in mind. So now let me suggest a fix, and then you tell me whether that's complete or not. Okay, what I can say is, not only that every element in the result is strictly positive, but also, let me add a conjunction over here, but also, every item in the result should also be an item in the array. Okay, I can say a dot has, and then I can say x dot item. Basically, what I'm saying here is every element in the result that we return, not only that is positive, but also is a member of the array. Now, is this good enough? Okay, good. Give me a counter example. Yes. Empty array, okay, empty array, that's true, yeah. Let's say, apart from empty array, give me something that's, of course, if you say result, simply just empty, again, it's gonna be true trivially, I agree. Give me another one that's not empty, but still can satisfy the postcondition, but it's wrong.
Just one number?
Yeah, exactly. So for example, we can say result over here, simply just one number there. It can be, for example, just 3. Okay, that will also satisfy, right? Let's try to view the problem a little bit more in a general way, because this is only one particular feature I'm trying to show you. In general, every time you're trying to return a collection from another collection, right? You want to really do a bidirectional assertion. That's kind of the idea. You guys learned about set comprehension, right? Okay, let me review that a little bit, okay? I want to just explain in the most precise way possible to you. So you can apply that to other examples as well. Okay, what we are really doing over here is we are trying to say two sets are simply equivalents, right? So we are trying to show equivalence between two sets. The left-hand side, we're saying for every x such that x is a member of the array. Okay, let's consider the array A over here just like a set, right? Set of members over there, set of numbers, such that x is also positive. Okay, so basically what this is saying is I'm using a set comprehension notation here, saying all elements in A, or positive elements in A. Okay, that's the set. Okay, that's the expected outcome. What actually returned is the following set on the right hand side. What actually returned is just another set. I would say y over here, such that y is just a member of the result. Okay? We are trying to say these two sets must be equivalent. Okay? Now, back in your 1019 or 1090, how do you prove that two sets are equivalent? You want to say they're a subset of each other, right? That's what you have to say. Okay? So now, if you think about it, let's say this guy here on the left-hand side, let's simply call that S over here, and this set over here, let's call it T. So now, what we just did up to now over here, what we are trying to assert is to say every element in the result is simply an element of the expected set that we are expecting, right? So now what we are doing is we're saying that T is a subset of S. That's what we have done so far. So what's missing? Well, we have to say another one. S is a subset of T. Now, can anybody help me on writing this? How do we do that? Right? That's a question. Okay, everybody clear what the picture is? So this is a very general problem we are trying to solve. Basically, you want to compare two sets to be equivalent. To really do that, you want to say they are a subset of each other, basically. So now, how do we do that in this case? Let me just use maybe green over here. So this is, let's say this is, I would simply say postcondition 1. Okay, just one tag. What about postcondition 2? Okay, let's finish this and then we're done with this example and then we'll move on to a new topic. Yes. Okay, let me break it down very easy. What do you have to go across over? Do you want to go we used to go, the one we had already go across the result. Now what should we go across over? A, right? That's what we want to go across. Okay, let me just do that first. So what you can do is, you can say across, let me write in orange. You can say across over here, and now the indices may not be so important, so we can simply go across all the elements in the array. You can also say across the A, and we're going to talk about iterable today. That's exactly the topic next. Okay, across A, which is a collection type, every collection in IFO is iterable. Okay, across A as, let me say X. Okay, and then no. Should I do universal or existential? Universal, good. So I should really say all over here. I agree. And let me, you know what? Let me indent it a little bit better. Okay. Now what should I put inside? Okay, help me out. Should I simply just say, well, let me do something here. You tell me if that's right. If I simply say result dot has x dot item, is it correct or not? No. What does that mean if I do it like that? Everything should be in, right? Okay, if I only say that. That can be another question I can ask you. I put it there, explain to me why it is not appropriate. So now what should we do? We can add an antecedent for the implication, right? So I can simply say, let me just move that a little bit to the right over here. And what I can do is, you can say x dot item larger than 0, sorry, implies. Okay, that's what I can do. If it is positive, that means it must be collected in the result. So that's the implication. Okay, that would be solution to this exercise here. Okay, try to really get used to the 3 postconditions we try to explain to you. Not only that they are very common pattern, but also they are kind of trigger your thinking, right? Yes? You will be caught actually, because, okay, good question. Let's try this. What if, let's say, you're basically asking if the result contains more positive number than in the original array, right? Let's make it down, write it down. That's a good question there. So far we got postcondition 1 over here and postcondition number 2 over here, right? Let's see this. You're basically saying, what about if the result is just going to be something like this? I have over here, let's say not only that it's 3, 2, and 5, I also got something mysterious, 23. That's the additional wrong one. So now, if you try to run postcondition 1, is it going to pass? No. There you go. Yeah, exactly, because when you run to the last iteration there, 23 is positive true. However, it is not. Oh, sorry. It is not a member of A. So it's going to fail that one. If there's duplicate, you mean in the result? Oh, I see what you mean. If you simply say 3 over here, okay, that's a good question here. In that case, let's say we put 3, okay, I really like it. So that's why I don't want to miss that, okay? So you pretty much know this guy here is going to actually trigger postcondition 1. That's what we agree, right? Let me do another one in different color so you can keep a record. Let's say you got result over here, and then you have over here, I like the question, I really like it. 3, 2, 5, and 3. Now, I agree that if you try to check postcondition 1, it's going to pass, no problem. Because every element in the result is simply an element that's positive in the array. I agree. But what about vice versa? If you try to evaluate postcondition 2, is it going to pass? Are you sure? So that means we may have to do a little bit more checking over here. I see what you mean. That's good. Any suggestion?
I was wondering, did we have one of the preconditions too? Is that you change it to 2, or is that?
Let's say we don't assume anything. Let's keep it very general. So you were basically asking, should we have a precondition saying the array simply contains unique element? Doesn't have to be.
When we were doing set equality?
It's more, yeah, true. Yeah, it's, let's try to keep it as general as possible. Yes. So now, in this case, what can we do over here? Yes.
In the second postcondition, add the occurrences.
Uh-huh.
In case if x dot, what is it? How does occurrences work?
Occurrences, well, simply say how many times it will appear, right? But you know what, guys, I think it's good that you think this way, but let me change my mind. What about we make a precondition here to make it a little bit easier? Okay, let's say we do have that to say over here, require over here, and then we simply say A contains no duplicates, let's say. Let's say there's no duplicate. Okay, now in this case over here, are we going to be fine? Still not, right? Because there might be duplicate in the result, which is beyond your control. It's up to the supplier. So in this case, I would suggest we can do the following. You can add another postcondition. What would you add? Well, you can definitely write another one to say the result should contain no duplicate, right? However, even easier, I can simply add another one over here. Let's say put it here, okay? The first one. I can simply say a.count just the same as result.count. That wouldn't be a problem. Oh, I'm sorry. So what I mean to say was, of course, this is not right. Beg your pardon. I didn't mean to say that. So now what we are facing here is we want to make sure everything is included that should be there. Yeah, question. Oh, actually, you know what? For this one here, no, actually it was okay. Let me just do it again. Maybe I'm wrong, but let's maybe try that. Sorry about that. So now, again, don't lose the big picture. We're still talking about this orange guy here, which is causing us trouble. Okay. So now let's say this. Apparently, you can see what's really missing from here was which elements? 5, right? 5 is really missing. So that means when you are trying to run this particular across loop over here, okay, the second one, and then you can see we're going to run over this, 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 and this, okay? So now for -1 and -4, because they are not positive, so that means the antecedent over here will just be false, which means we don't care, right? However, let's say that for the case of 5 over here, so now x.item, which is 5, larger than 0 will give you true. However, 5 does not exist in the result, so it's going to give you false. So there's going to be a violation. So which one am I? Oh, just getting the duplicate, right? So that's my problem. Yeah, how can we fix this? Yes, go ahead.
For postcondition 2, say
Yeah.
x.item greater than 0 implies result.occurrences of.
Yeah, Yeah, unavoidable. You guys are better than me, actually. Yeah, which I like. So which means I gotta challenge you more, right? Oh, no, I'm kidding. Okay. Okay. So basically, what we need to do is something like this. Yes, I agree. You have to do something like about permutation. Well, not permutation, occurrences. Okay. Let me try to put this guy here. Give you a hint. Try it out, and then I'll give you the complete solution. Maybe on Wednesday. Okay. You can see this one's really tricky, right? What I can do in the exam, I can start with just number 1 over here. And then I want you to really add in as many postconditions as you like to make it complete. And write down your explanation. Right? That's kind of what I need. Okay, so now let me give you the hints how you can fix it. So for this guy here, the second one, somehow you have to incorporate occurrences to see exactly, because you can see for 3 over here, it appears twice in this result. On the other hand, 3 only appear once in the A. So there's some mismatch over here. We want the postcondition to address that. Okay, I'll write it down next time to present to you the complete view. Okay, it's getting a little bit messy here, but hopefully you see the discussion. Okay. Okay, are we okay so far? Despite that, we haven't got a final solution written down just yet, but we're getting there. If I come up with any more interesting exercise for postcondition, I'll let you know. Okay, we definitely do the exercise together. Good. Any questions? Good. Now, let's move on to the topic for today. We're going to talk about basically design patterns, and the first 2 we're going to talk about will be iterator and singleton pattern. Iterator is exactly relevant to what you're doing for lab number 3. Okay, and I will try to cover as much as I can today. I'll also like to maybe take the last 10 minutes of today, talk about something else in lab 3 to help you a little bit. It's a challenging lab, I know. I'll try to help you a little bit, if I may. Good. So now, in order to understand design patterns, there are 2 things that are really critical. One is about using generic parameters, which we did cover 2030, depending on who you take it with, right? That's one thing. And number 2 is about inheritance. Inheritance, we're going to cover that in complete details, maybe from next week. But for this week, at least we can try to cover iterator and singleton pattern. For these 2 patterns, you don't need that heavy amount of inheritance, not yet. But we will need it, especially for visitor, state pattern, and observer pattern. These are very important patterns for you to learn. They do rely heavily on inheritance, but we'll do that possibly after the reading week. So now, let me talk about generic parameter quickly. Okay, I'll give you some challenging exercise to do, maybe next time or next week. Okay, first of all, let's talk about how you can use generic parameter. Let's say we have a stack class. You know, that's kind of the hello world example for generic class. Let's say we got a string stack over here, which means we're going to store strings only in the stack. Okay, you can see I'm trying to say implementation here is an array of string. Okay, and then we have some counter over here to tell us where the top of the stack is. Okay, and then we got count over here, which is a query, and then also we got top, also we got push, and we got pop. The implementation here is very trivial. You knew how to do it from the previous course, so I don't need to bother you with that. Okay, so now let's think about the following issue. Number 1, the way we implement the top and let's say the push and pop, does it really depend on what type of elements we're storing in the stack? Does it really depend on that? We'll put it another way. If I now want to say, rather than having a stack of string, I want to have a stack of accounts. Do I have to change the way I implement the stack, the algorithm? Well, nothing to do with different. I'm just saying, focus on this current design. The current design, somehow, the way we do top, push, and pop doesn't really depend on what the type of the element we are storing over here. It's really about we're trying to implement the last in, first out rule for the stack, right? Last in, first out can be applied to any stack of elements. It can be stack of string, or integer, or double, or account, or even binary search tree. Doesn't matter, right? So now, let's try the following. One more thing to see. You can see that in the stack class, we do not try to make use of any feature that's specific to string. For example, you can see the append or the add feature. We're not using them at all. We're just trying to implement the last in, first out. Okay, let's try to be a little bit more precise over here. Okay, the answer is no. But now, let's say I want to get another stack done. Okay, let's say account stack. Now, what should I change? Let's say I copy and paste this fragment of code. What do I have to modify? Do I have to modify any implementation? No. What should I modify? The type, right? If you are careful enough, exactly what I highlight in yellow over here, right? Exactly that, okay? Which means I'm going to change from string into account. That would be my account stack. Let's have a look. Account stack, and then rather than an array of string, it's going to be an array of account, right? And then also the way we count how many elements are in the stack, just the same as before. Nothing changed. And then we're going to say the type for the top should be account. And then for push and pop, just change the parameter type, nothing else. Now, similar issue. What if I want to have a stack of binary search tree? Just change the type, exactly. So now, the way this particular collection works is irrelevant to what type of element you're storing. Whenever you got such situation over here, your design intuition should tell you you should use generic parameter. So now, I'm also trying to give you a very quick intuition about how you can use generic parameter. However, there's deeper rationale how generic parameters should be understood, for which we have to cover inheritance, polymorphism, and dynamic binding first before we get there. Okay, so there'll be two angles I want to cut into the topic. But for now, just keep it easy. So now for the account stack, okay, you can see that nowhere in this stack class are we trying to use deposit or withdraw, all right? Okay, so it's not relevant. Good. Basically, you can see any collection in general. So now I'm going to talk about design decision here. Whenever you want to design a collection on your own, you have to really think about, does the way we retrieve or to store the elements in the collection really depend on the element type? If it does not depend on that, you better parameterize the type of elements into some generic parameter. Okay, so let's see exactly how it looks like. So now let me compare for you over here. Okay, basically this is just a duplicate of the code we talked about. For example, you can see that for implementation here, you can either use a string or you can use an account. And then everything else will be changed accordingly to whatever element type you're doing, right? So now, how do we use generic parameter? From the user's point of view, you can think about, we want the clients of the stack to make some commitments. When they try to declare the type of their stack, you can see currently they might just say string stack, and then they will simply say string stack. They might say account stack. They can say account stack over here. That's how they're doing here, right? We like to change the way client is going to use the stack. This is how we're going to change it. Okay? So this is the old way of doing things. We want to change it to something like this. If I want to do a string stack, I simply declare stack over here. Okay? Similarly, for account stack, I can also say stack over here. And now I want the client to do something more for me. I want them to commit to what kind of elements you want to store in the stack. In this case, the client can choose. They can choose any reference type. They might choose over here string. Okay, in this case, every element in this particular stack instance is going to store string only. Okay. Similarly, they can also choose to put maybe account over here, in which case every element in this particular stack is going to store account only. That's kind of how you use it. Okay, so we are putting more burden on the client side. Let's have a quick look. What will be the consequence of that? Okay, so now you will see that this is how you declare your class over here. So far, you're using generic classes already many times for lab 1, lab 2, and lab 3, right? For example, sorted model map and sorted map ADT, they're all generic, okay? And you haven't really defined from scratch a generic class yourself. Maybe you did to implement the iterator pattern, but that's something we'll talk about today. Later on in your projects, basically every time, if you have to define a collection by yourself, you better make it generic. That's a very valid design decision to make. Okay? Now, let's have a look at how we can design the generic class, right? So we first of all give a name for the class, and then we say square brackets over here, and then we declare some parameter name. Okay? So the parameter name can be any name you like, as long as it does not clash with any existing classes. For example, you simply just cannot say stack and then you put integer over here. If you simply put integer over here, it's not correct, because integer clashes with some class name. But typically, you just choose a one character symbol, for example, G. I think in Java, they simply like to use I or J or K, something like that. Okay, just in IFO, they choose G. And now, one thing to note, okay? So now, and then, this is declaration. Okay, let me just be clear about it. So this is where you declare the generic parameter, that's declaration, at a class level. The G over here, I'm going to use a different color, G over here, and a G over here, right? They all refer to this particular G. Okay, so now these are all references. Which means depending on what the client instantiated G into at the class level, all the G over here in green are going to be instantiated accordingly. So what do I mean? Let's just see one example here. Okay, so now let's see for this particular one. Let's say, so we talk about supplier over here. Let's look at the clients. For the clients, let's say we have this particular stack over here, right? So SS, and then it's going to be a stack of string. As soon as we see that one there, so that means the client decides to instantiate this particular G parameter over here to be string, okay? And the consequence is every G over here is going to be changed to string accordingly. Okay, and again, what's the further consequence of that? The further consequence is now the compiler has information to see what kind of element can you push into and pop from the stack. Let's see example. So now let's say if I say ss.push A, does this line compile? Okay, you can think about why. You can see this is a string literal, this is of type string. And now, what is the parameter type for push in this case? Well, generically speaking, is G, right? But now, because the context object over here has instantiated G to be string, that means for this particular instance, whenever you try to push, it has to be, if you see the push over here, it should be a string. Okay, that's what we have changed. On the other hand, let's use a different color here. If I try to do SA for stack of account, you can see now we are trying to instantiate a G to be a different parameter, right? Different class. So that means the G over here is going to be, I would say A for account instead, the orange one. That means for that particular context object, every instance of every occurrence of G will be replaced by just account here as in orange. So now, if you try to have a look at over here, oh, let me just, before I look at something that's invalid, let's look at something that's valid. What about if I say this line over here? When I say sa.push, and then I'm simply pushing a new account object, is this going to compile? It is, because you can see that for this one, the context object is simply SA. For SA, we have already instantiated the G by account. So that means the push right now is expecting just an account over here. So that means it compiles. Okay, so far so good. Let me just do one more with you. If you look at line number 7, is it going to compile? No, it's easy to see, right? Because you can see the context object here is SS, which means every element should be of type string. In that case, you cannot give a account object over here. Okay? As far as the usage is concerned, I only require you just understand up to now. But after we talk about deeper about polymorphism, dynamic binding, we'll see a little bit more about the details here. Okay? The very good, the biggest advantage for generic parameter, number one, you can really reuse the same piece of code for generic stack and just instantiate G to be any type you like. That's number one, about code reuse. And number two is really about avoiding doing typecasting, which we have to see in the context of inheritance. Right? You see lots of casting in Java code, but generic parameter can really minimize casting for you. But we'll see why a little bit later. Any question about using generic stack? How you define it and how you use it? Okay, we'll see more examples when we go to the iterator pattern. Okay, that's about the stack over here. Okay, you can also see, I'm just trying to say instantiation. You'll see that in the slides, but we just gone through that. Okay, for the client, just have to, okay, that's the same piece of code we just went over. Okay, no questions so far? Yes. Good question. Can you implement a stack where you simply store maybe different types? Good. I like that. That means let me maybe look ahead a little bit. Okay. Maybe I want to add page below over here like this. Okay. Yes. Thank you. I forgot. Okay. Let's say this. Let's say I have a class over here. I simply say class. Let's say my collection. And then I simply say G over here, and then N. And then I have some implementation. Let's presume it's actually export to none. And then it's simply just going to be array of G over here. Okay? So now this is the supplier part. Okay, let's now do another one for clients. Now, if I do the following, if I say stack of, let me just say S. This is something I haven't told you yet. When I instantiated before, when I say SS is of type stack of string, it can be storing not just string, but also all the subclasses of string. And when I say SA is of type stack of account, you can store any class as long as they are subclass of account. Following this thread of thought, if you want to be very accommodating on what to store in the stack, what type should you put so that it's more like a common parents for every class? Any, exactly, like an object class, right? So now, I'll tell you what can be very bad, okay? We can we'll actually reiterate this discussion again, but I will want to repeat. Let's say we have stack, let's say my collection, and then I'll simply say any. So now you got an incredibly flexible stack, which means you can say s.push. I can push a string. S.push, I can also push an integer. S.push, I can push maybe, I can just do create, I can create maybe binary search tree, as much as I like. I can just push anything I like. In the case of storage, it's very flexible. You're gonna suffer when you try to retrieve from there. Because now, if I have, let's say it turns out you got 100 kinds of elements, it's possible in the stack. Potentially it can be infinite number. Any class can work. So now here's a problem. Let's say I try to do the following. If I try to say s.pop, okay? Now, what's its type? Well, statically speaking, as far as the compiler is concerned, they only know that it's an any type, just anything. Because you store anything into it, whatever you can retrieve can be anything, intuitively, right? It's fair game. So now, let's say I really believe this particular, when I say pop, the current top should be account. Let's say I do believe it, right? So now, if I say s.pop and then dot deposit, let's say I do believe that. However, it's not going to compile. Because as far as the compiler is concerned, it's going to be any type. Any does not support deposit. And what you really believe to be the actual dynamic type for s.pop is cannot be checked by the compiler. For those of you who learned about 2001, to really keep track of the dynamic type is an undecidable problem, which means you can never ever write a compiler that's going to tell you at this point of the program what is the dynamic type for this particular feature. If you can write such program yourself, you definitely you don't need this degree. You can get a Nobel Prize already, right? It's just not possible. That's my point. Okay. Okay. Hopefully that's kind of makes sense. Yeah. So let me. I will definitely revisit this discussion again because it's really important in one moment. So now, what lesson have we learned from this particular example? Whenever you try to do generic type, never ever give too generous type over here. You're gonna suffer when you try to retrieve from there. That's the problem. Yes. Yes, that's exactly the point. Yes, you may do cast. Think about, let's go a little bit further. Yes. Let's say we got 100 kinds of elements over here, right? So in general, you may have to do the following. You might say as the pop, let's say top, right? Because pop will just pop it already. If as the top, okay, let me just write the notation you're familiar with. If I say instance of account, then I might do something with the cast, right? Else if as the top, let's say instance of, let's say string. In that case, I can do something else. Now, given that I know I got 100 kinds of elements in my stack, how many if and else if do I need? Up to 100. So you don't want to do that, right? That's a little bit too, your code smells, basically. Okay. Oh, we'll see that, yeah. Okay, anyway, the bottom line is learn this lesson. Never ever instantiate a generic parameter to be any. You're basically just as if you didn't use it. Okay, that's good. Now, let's talk about design patterns. So what's really design pattern over here? So for this course, we're going to talk about, before the reading week, we only talk about iterator and also singleton. So these are the easy patterns. But after the reading week, we're going to talk about some major ones, which are tricky. State pattern, visitor, observer, and at least these three, but we'll get there. Okay? So design patterns, basically in the software industry, they got recurring problems to solve. For example, if you want to implement a hotel reservation system or air ticket reservation system, the underlying problem can really be simplified into a DFA, deterministic finite automata, that you learned in 2001. And for this kind of problem there, you would know you want to use the state pattern. On the other hand, if you want to implement, let's say, hierarchical structure for, let's say, the computer hardware, right? For each hardware, it's more like a composite structure. You got the cabinets for your hardware. Inside the cabinet, you might get as many motherboard as you can. And the motherboard, each one also got different components there. It's more like a hierarchical structure. In that case, you wouldn't want to use a state pattern. You want to use another pattern called composite. Okay, so my point is, you have to see what kind of problem you're dealing with. And then you want to choose the right solution for that. Okay? One of the reference book for this course, you can look up the syllabus. It's actually a catalog of design patterns, about maybe more than 40 patterns over there. But we're going to teach you all of them. It's not the point. We just want to show you the most tricky ones, especially visitor and state pattern. Once we show you these two, hopefully that will get you interested. Try to look up for your own sake, for the textbook by yourself. All right, so now we're going to learn about design patterns. Number one important thing to know is you want to know what's the context of application for a particular pattern. It's not necessarily a pattern can be applied for all the contexts, not really true. Okay? A very typical exam question would be, we just give you the problem, and then we say solve it. Number one, maybe part A, for this particular problem, what should be the pattern you use to solve the problem? Part A. And then part B, you can actually try to solve it, use the pattern you actually proposed, right? But I would say typically the problem that we want to teach in this course, you should be rather straightforward what you have to use. Okay. Anyway, still a bit abstract, but I just want to get things clear before we get to the pattern. Okay? Always understand what the problem you're trying to solve rather than solution. Okay? Good. So now let's talk about iterator pattern. Okay? Now, again, I would think understanding the problem itself is more important than the solution. Solution is very easy to implement. I can literally talk about it in 2 minutes and then refer you to the slides. But it's really important to think about the design issue over here. What I want you to look at is fragment of code over here. Okay, it's on the slides, but it's easier for me to put things here. I can annotate. Now let's think about we got supplier and we got clients. Right, got two sides. let's say for the supplier, we're trying to define the shopping cart class, where we got simply an array of orders. At the moment, you can see for the feature, there's no exporter to none. That means anybody can get access to this particular array, which might be nice. You just want a client to be able to get to the array and do whatever computation they like. Might be a nice design decision. We don't know yet. And then we got another class over here called order. The order simply represent each order on, let's say, on the online shopping system. You got price, and then you got quantity. For simplicity, let's say they're simply integer. Okay? We got two classes on the supplier side. Okay? And then we got another class called shop for clients over here. And then for the clients, they simply got a cart class, which is called cart. And one thing to show you. So far for each of the labs you were assigned, we gave you the bound diagram to read, right? I'm going to go over some of them today, hopefully in the last 10 to 15 minutes. Whenever you see such declaration over here, as we said before, the current class is called shop, is the clients. And we are trying to use the cart class as a supplier. As soon as you see this, you can imagine the following bound diagram. Okay? You can think about, you have the shop class, which is the clients, and then it's going to use some service from the cart class. And then you have some client-supplier relation over here, right away, client-supplier. And then on top, you can also put a label to say what kind of service we're using. So the shop is using the cart as a cart. That's how you interpret that. Okay, it's the simplest bound diagram you can draw. Okay. Okay, and now we also got a checkout feature for the clients, whereas we say, okay, it's just a very standard way of writing loop. Okay, using lower, upper, and also we try to use an indexing notation for array, and then simply make sure you say I is assigned to I plus 1, just calculate what's the total price for this particular order. That's what the classes are about. Now, any problems over here? Anything you can think about. Something to do with design. Yeah, don't tell me that maybe we could have used a linked list rather than array. Let's say I want to stick to array, okay? Although I might change it to some other implementation in the future. I might. It's up to my discretion. Okay? Yes, go ahead. We are assuming, say that a little bit more, yeah. What do you mean assume?
Orders high.
Yes.
Let's say it goes before something else. We'll try to
No, okay, over here, you can see that we're simply, you can see car.orders is simply just an array of order, right? We simply go from the beginning until the end, just aggregate the price. Nothing wrong with that.
Assuming that the array is filled from left to right.
Let's assume that, yes. Let's assume array is always going to be filled, let's say. Let's assume that, yeah. That's okay. No, that's not a problem, yeah. That's more like an implementation issue there, yeah. More about design issue. The code in where? In the clients, okay. You want to say something as well?
Suppose for the client, if you're client of the cart class, in this design, you also have to know the method for the order class.
The order class, yeah, of course, it's part of the interface for sure. Yeah, that's not an issue over here. Yeah, are you mainly talking about over here? So you can see that when you got, for example, orders at position I, is of type order. Of course, you can get quantity and also price. That's not an issue.
Is there a problem with result?
No. No, not a problem with result. Actually, it's okay because we return integer. Result just aggregating all the price. Okay? What you just said is exactly correct. Okay? But maybe not many people heard that. That's good. So we can still think. So now, let me clean this a little bit. Okay? So now, since we say it's a design issue, when you think about design, it's always important to think about clients and supplier, okay? Of course, this has nothing to do with contracts, okay? It's just different angle to view the design. Okay, let me just clean this and then explain what the issue is, okay? Basically, what's really happening here is like this. At the moment, the supplier decides to actually implement their orders using an array. If I'm the supplier, I'd rather that I have the freedom to change from one strategy to another. Maybe tomorrow I decided that I want to use a hash table to implement my order, or I want to use a black tree. I should be able to do that, right? It's up to my discretion as a supplier to do whatever I can to satisfy what the clients need. However, it's not a problem when the supplier changes their mind internally. However, if the change on their strategy is going to affect the clients, that's not good. Because clients should not be bothered by any changes you make in your internal design. So what do I mean? So now, let's say if I decide to change my implementation over here, rather than array, I'm going to use a linked list, for example. After this, I hit compile. Doesn't work, okay? Why does it not work? Which side? Which side wouldn't compile? The client side, which line? There's no lower for linked list. There's no upper for linked list, right? And also, yeah, that's one thing. Which one? You mean the indexing notation? No, it's okay. Actually, when you say car.orders, it's not going to be a tight linked list. It just, there's no lower and upper. Oh, this one here? That one's okay. For the linked list, you actually can use the indexing notation, but you at least got these two things that wouldn't compile anymore. So what's happening is as follows. When the supplier changes their implementation strategy, which should have been kept as a secret, when they change it, it's not a secret anymore. It's actually going to affect the client's code, and everything on the client side suddenly wouldn't compile. They would be very upset, right? Because for me, I shouldn't be bothered by whether you implement using an array, linked list, or binary search tree. I shouldn't be bothered by that. But when you change it, I just got affected. Let's say like this. Let's say okay, sure. If you want to use linked list, maybe I'll simply say from I is assigned to maybe some cursor, and I'll just make everything compile for now. But tomorrow, the supplier decided I'll use a hash table. And then suddenly everything will just not compile anymore, right? It's kind of like a needless game to be played, between the supplier and the clients. So now so this is why, even though implementation might work, but as soon as you change the implementation strategy, everything will stop to work. That's a design problem here, okay? The problem is something over here that should have been kept a secret over here, orders, that should be kept as a secret. It should be hidden from the clients. It was not hidden. That was a problem, okay? So now, this has to do something called information hiding, which I will go over right away. It's a design principle, the number one important principle. Yes?
So basically, if it's supplier side, all features should be hidden?
No. Good question. Not all the features. I tell you what, it's interesting. If you hide all the features in the supplier, nothing can be called by the client, right?
No, but I mean like from the
Oh yeah, so okay, maybe it's a more general question you're trying to ask. What should be hidden? Good question. We're going to present this principle in just a moment. I'll give you some intuition. When you are trying to design your classes, think about what attributes might be subject to changes. Those attributes, not a single one, maybe those set of attributes should be hidden. So you have your discretion about changing them from one to another without affecting the clients conceptually. Okay? Or let me draw your diagram quickly. It's really important. It's a number one important principle for this course over here. Okay? So now you can think about like this. If you think about this is the entire thing for a supplier, and let's say we have another client's software over here. That's a client, right? You can think about, you can divide the parts for supply into two parts, okay? It can be, so the red part over here, okay, simply this part here. And also the green one, okay? Just make it intuitive for you. This is the green one. Okay, you just got two parts in the supplier conceptually, okay? So now this guy here, the red one is the hidden part. Hidden, which means they are subject to change, to changes. The case of the order array over here is one of the example. It might change from one data structure to another, okay? But for this part here, it can be as many features as you like. It doesn't have to be just a single one, okay? Now the green part over here is so-called interface of your class. So this is the public interface. which means any potential client should only depend on this particular code over here. That's the only part, not the secret part. Okay? The problem for this current design is orders was actually put over here, whereas it should be put over here. That's a problem. Okay? And there's a name for this. It's called information hiding principle, which we'll see. Okay? Okay, let's now go to iterator pattern. So we have seen that. And then that's exactly what we just said, right? So you got to change that. Okay? But now you can see that this is not really a good fix, because even with this particular fix, the orders is still exported to any, which means you can still change it tomorrow. Okay, so now we're going to talk about iterator pattern, but before that, I'm going to go over into detail with you. That will also give you some inspiration for lab 3. Before I do that, I would like to talk about information hiding principle. Okay, so that's a #1 important principle. So one is, there are 2 principles that are really important. One is called information hiding. The other one is called single choice principle, which we'll get into when we talk about inheritance. Okay, so what's really information hiding principle? That means you want to have a very stable API, okay, the green part over here, right? You want to make sure this part is as stable as you can. You should never change this part. You should never ever try to change this part. And then anything that should be changed should be the orange part, okay? Okay, and then changes of secrets does not affect the client using the existing API, right? So now when you try to change the orange part over here, it's just not going to affect the green part, which means the client, all their code will still compile, not a problem, right? That's information hiding principle. Okay, so changing from array to linked list is a very one example. So now in general, it can be a set of attributes or queries that you want to change, right? That you can maintain. Okay, so now let me just go over the iterator pattern with you. Okay, I'll go over the architecture with you. Okay, and then it's more like a case study for the block diagram. Okay, I do know it's too small, so how about this? That's better. Basically, we've got 2 sides to worry about. We got a client side, and also we got a supplier side. You can see the supplier side is this big. That's the supplier side, right? The client side is very easy. Let's look over the client side first. Okay, I'll also make available the diagram to you after the lecture. So now, first of all, let's see. This is the clients, okay? And then the #1 important thing for you to know is when you want to, for the client to use the iterator pattern, they have to say iterable, which means this container over here can be any instance whose type is a subclass of iterable. In your lab 3, what is a subclass of iterable? I hope you have started looking at that, right? I hope. Sorted map ADT, right? Okay. If you do me a favor, go to sorted map ADT class, you will see that it inherits iterable. Okay, please have a look at that. Okay, otherwise you get stuck. Okay, so now this is what the client side has to do. Okay, the client just have to declare something of type iterable. Okay, and then after that, let's say this is a container, right? Once you declare something that's iterable, you can use the across notation. Okay, I will give you one example over here. You can see this one here. Okay, let's have a look at that. Make it bigger for you. You can see the container over here was declared as iterable. That means you can always make use of the across keyword to go across it. Okay. And then, of course, you can use the notation that we are familiar with, but I'll give you more details as we talk about it. Okay. And of course, we got item feature over here, which you have to implement if you're trying to implement an iterator pattern. So that's about the client side. And because we are having iterable over here, that means, as I said, you have a client supplier arrow over here from the client to the supplier. And over there, you also have a label called container, right? Because container is of type iterable. Right? You can see this is the client and this is the supplier. Are we okay so far? Okay. And now another thing to clarify, okay? Whenever you see star over here, that simply means the class is deferred. Deferred in the sense that there's at least one feature in the class that is unimplemented. Okay? And then when you got plus over here, let me just be better. If you say plus over here, it simply means deferred, which means at least all the features in this class have been implemented. Yes, questions? Oh, the plus, yes, exactly, yes. Oh, there's another one, which I'll mention when we see that, okay? Plus and versus star, yes.
Oh, what was the difference?
Sure, the difference is, you can see that over here, typically star means you're kind of at the top of the hierarchy. You simply got at least one feature that's unimplemented. For example, for the case of iterable, the feature that's unimplemented is called new cursor, which I'll give you more details in just a moment, okay? On the other hand, for the client's code, it's simply effective. Oh, sorry. I really meant to say effective. Sorry about that. I really meant to write effective. I'm not sure why I wrote it deferred. Not too sure. Okay, it should be effective. Yes. Yeah. Okay, so now are we okay with the client side? Client side is very easy. Okay. Now supplier side is going to be exciting. Okay. That's exactly where the complication comes from. Okay, which is nice. So now, for the supplier side, my way of understanding it is as follows. If you want to implement your class as iterable, for example, your sorted model ADT or sorted map ADT, right? So there are two ways in general for you to implement it. Two ways, easy way or the hard way. Easy way in the sense that if you already got a collection attribute over there, you can simply just use the new cursor feature from there. I'll show you, okay? The hard way means the way you put the attributes together simply don't have the new cursor feature supported. You got to implement that yourself, which is what you have to do for lab 3, right? But that's not too bad, okay? Let's try to go over with you, okay? So now let me just explain the architecture over here, and then we'll explain the two cases, okay? And then for the slides, you can definitely refer to the sample code I gave to you. If you go to lectures page, there's also 2 tutorial videos over there for you to learn about iterator pattern and also generic parameter. Okay, I will send you the link after today's lecture. It's also very straightforward for you to follow. Okay, so now this is how we can do it. Let's understand the architecture first. We got this iterable class, that's the most critical class. If you want to have your class being supported by the across notation, you must make sure your class is a subclass of iterable, okay? And then the only feature you have to implement is called new cursor. Because new cursor, you can see there's also a star over here, right? That means it's unimplemented, okay? In the iterable deferred class, they got only one feature for you to inherit, which is called new cursor, and that one is deferred. You want to make sure your class, if it is not deferred, you must implement a new cursor feature. But now the question is, how do we implement a new cursor feature? The easy way or the hard way? Okay, we're going to see that. Okay, so now we got new cursor over here. So let me just show you one more thing here. You can see what is the return type for the new cursor. Okay, let me just make it even larger here. You can see the new cursor is of type iteration cursor. Okay, so now is this suggest the green one, is it suggesting a client supplier or inheritance? Client supplier or inheritance? When would you have inheritance? When you say class A inherits class B, that's how you see the inheritance, right? Whenever you see a declaration of a type, it's client supplier, easy, okay? So now, as soon as I see this particular declaration over here, you can see iteration cursor, which is the return type for new cursor. I do have a client supplier relation here, which means iterable is the clients, and iteration cursor is a supplier. Okay, let me just write it. So that's why you got a client supplier relation over here from iterable to iteration cursor. Let's not worry about the generic parameter just yet. I'm going to give you more details next time. Okay, and then the label over here is simply new cursor, right? It's simply star because it's not implemented yet. Okay, so that means if you simply get access to this particular new cursor feature, what kind of feature can you call on new cursor? You have to look at the interface for iteration cursor. Let's have a look. Okay, that's exactly what you have to implement actually for your lab 3. You're going to implement a feature called after, a feature called item, and a feature called fourth. So these are the standard operation for cursor movement, which you learned previously, well, just in a different language, right? Are we okay so far? Okay, now, so iterable and iteration cursor is more at the interface level. Let's talk about how you can implement that. let's talk about what you have already that you can feel free to reuse. So you can think about all the collection classes in IFO, including, for example, you got, let me use here. You got array, you got linked list, you also got array list, also hash table, tree, etc. All the collection class. They, by default, they are all inheriting from the iterable. Okay, so this is inheritance relationship, right? So typically either have client supplier or have inheritance, right? All the collection classes in IFO, they are subclasses of iterable, which means array is iterable, linked list is iterable, also array list is also iterable, hash table as well, right? So far so good? Okay. And to give you a little more detail, let me just finish this and I'll take your question. Let me give you a little more details here. For all these, for example, array, linked list, and array list, right? Since they are not deferred, that means when they inherit this particular new cursor feature that is deferred, they have to implement it, right? That is why you see another client-supplier relation over here. Okay, it's called new cursor. Notice that we got star over here as opposed to star. Sorry, we got plus over here as opposed to star. That means at the level of array, linked list, and array list, the new cursor feature is implemented, right? At the level of iterable, it's not implemented, it's deferred, okay? And now you can see that, oh, there's another class you can look up. It's simply the indexable iteration cursor, and then with all the features implemented. So you can see plus, 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 and plus. Okay, I'll pause a little bit for questions before I go on. Yes, question.
So the only feature that iterable has is new cursor.
Yeah.
Why are we not directly getting the methods that iteration cursor has? Because new cursor just seems to be getting the methods.
Yes. So it's more like a separation of concern, really. So when we talk about your question was, I think it is also more like a design decision by the language library over there. You're basically asking the following. You can see the only useful feature in iterable seems to be only the new cursor. And the new cursor simply got after item and fourth. Why don't we simply support after over here and also item and also fourth? Why don't we do that? Okay? It's more like a design decision, more like a separation of concern. When you talk about iterable over here, you simply say, for my class specifically, I just want to say that one can be using the across notation. I don't necessarily suggest you're going to use a cursor operation to support that. However, over here, iteration cursor is just another one that supports cursor operation specifically. Just a separation of the two concepts over here. Yeah. But you're right. If you try to implement your own class, feel free to do that if you think this makes more sense for you. Nothing wrong or right. Yeah. Okay, so now, are we okay with this diagram here? Any questions?
I'm not sure. So let's say you just did across, you want to do an across on an array, so you would call new cursor?
That's a very good question. Yes, in theory, you can definitely use new cursor on an array. Yes, you can, but we typically don't do that. As I will show you in the example. You can either across array directly, or you can you can use the new cursor from the array. Either way. You will see the example. No, when you say across, okay, your question was like this. So when do we use new cursor and when do we use across directly on the iterable? The answer is you can use both. Okay, just two flavors for you to use, right? For example, over here, when you say across over here, the container, you don't see anything new cursor, right? Implicitly, new cursor was there. Implicitly, it's as if the cur over there is a local variable. Implicitly, you say cur is assigned to container.new cursor. Implicitly. Okay? You can write it out explicitly as well, but we'll see example. Okay, good. Guys, are we okay so far? Okay, good. What I will do now is I'm going to show you two ways of supporting iterator pattern. Yes? Can you use more than one new, what do you mean? What you use more than one new cursor?
More than one cursor at the same time for a collection.
Yes, you may, provided that you don't really modify them concurrently. You gotta be careful with that.
Yeah, that was my question. Suppose if one tries to modify the
So I think that you run into some contra violation at the runtime to say you're trying to modify some new cursor which share the same data structure. But that's a bit more advanced. We don't have to worry for now. Yeah, but you're right. That's a practical issue there. Right? I believe you get some like a concurrent access to iterator exception in Java as well, right? If you're trying to get a cursor to the same data structure, but you're trying to modify that at the same time, then you can run into issues. Yes. Yeah, it's more supported at the, so you will still be some contra violation occurring at the runtime. Yeah. Okay, guys, let's, okay. We got about 15 minutes left. I want to at least show you what you can do quickly, and then on the diagram. Okay, I will go over this diagram here, which will give you intuition about runtime iterator. I'll go over this maybe on Wednesday. I do want to talk about lab 3 to give you some help. Okay, let's talk about this one very quickly. Okay, so now let's say the following. So there are 2 ways for you to support the iterator pattern. Okay, easy way. Okay, everything's on the slide. I want to just show you. So now, if I want to make sure I can support card to be iterable, I can say inherits, okay, iterable. And now, always you have to instantiate a G for iterable. Now, what should we put over there? Intuitively, this is what you can think about, but I'll give you more challenging exercise to do, okay? Which will, maybe you have to do lab test 2, okay? Still undecided. So now, what should we put inside over here? Thinking this way, you can think about the iterator pattern is to have a way to really have the clients get access to your underlying data, one item after another. What should be the type for that single item every time? In this case, it should be order, right? Because we talk about card, right? Even though the underlying data structure is array, but it might be changed from array into linked list to a binary search tree. It doesn't matter. As long as the supplier can return to you one item at a time, that's iterator pattern. But what should be the type for each item? In this case, order. Okay, we'll see more example next time. Order over here. So now, this is a very trivial implementation. Okay, I'll show you. So that's why easy way is very good, if you can use it. So now, once we say inherit from that, we're gonna say new cursor right away, right? We're gonna implement that. New cursor, iteration cursor, and then it's gonna be order. Okay, now, what should we do in the body of the new cursor over here, right? Let me give a little bit hints over here. If I go back to this particular architecture diagram over here, let me clean that a little bit, and I'll show you exactly what's going to happen. Okay? That'll be good. Okay, I'm talking about supplier side over here. Okay, just like that. Oops. Okay, that's good. So now, how do I implement that? Let me just give you a little bit hints here. Basically, what I'm doing here is I say that my card class is going to inherit from the iterable. Right? Agree? That's what I'm doing here. So now the question is, how do I support the new cursor feature? I'll give you a little bit hints. By the way, it's an easy solution, so it must be very easy. I want you to look at orders, which is the internal attribute for the card. And remember I said every collection is iterable, which means by default, there should be already an iterable new cursor feature defined on the array. Agree? Why don't we use it directly? Get it for free, okay? That means over here, thinking this way, the card has a client supplier over there, right? Client supplier over here, which is card. Oh, actually orders. Orders over here. Okay, agree with this particular client supplier. And now what we can do is, the array over here has a new cursor feature. We can use it. That's the first solution. Which means over here, it can be as easy as we can simply say result simply assigned to orders dot new cursor. In this case, we're lucky. We only are using a single array to represent the order. And then we can just use the new cursor feature from there for free. Okay, that's an easy solution. This is what you were given in lab 2. I'm not sure if you look at that actually, but if you're not, that's okay. You can look back in lab 2. That's exactly how it was implemented for lab 2. But for lab 3, you have to go to the second way. the not so easy solution, okay, which I'm going to show you quickly. So now for the hard case, let's see this particular case over here, right? So now I'm just trying to give you another example so you can hopefully extrapolate from that. Now over here, what we have is, let's say we have a class called book, generic book, okay? And then I also have names and record. Basically, we've got two parallel arrays, and one for name and the other one for records. And the name and the record at the same position represent the record, right? The name and record pair, okay? It's easy. So now the problem is I cannot necessarily use names.newCursor and records.newCursor together. Okay, naively, if you simply say names.newCursor plus records.newCursor should be the new cursor for this book, right? Naively, that's how we think, but it doesn't work that way. That's a problem. So now how can we support it? The way to support it would be, let me just write it down for you. So in this case, again, we're going to say inherits iterable. Now, what should we put over here? Again, the way for you to think about this is, think about the clients of the book is going to get access to the whatever that's being stored one item at a time. What should be the type of the item over here? Huh? G? Well, if you only say G, okay, if you only say G, I tell you what the issue, it will compile, but it wouldn't work as you might expect. If you only say G, remember G is only the type for the record, but you're missing the name, right? Yes, right? Yeah, that's true, but of course you shouldn't use any, I agree. But that doesn't mean you cannot have something else. Yes, Ken?
A tuple of string in G?
Aha, a tuple, right? You learned about tuple, right? In your lab so far. So basically we just kind of collect, the two pieces of information here, name and the record, okay? Very good. So what we can do over here is we can say over here, tuple, and then we can have, basically you can have G, string and G, okay? Just a tuple, okay? Of course, I thought this might be a way at least to show you what's the process. You got to program that by yourself to really see it, okay? Now, what we should do is thinking this way, right? We have new cursor over here. However, we know that the existing support from array or from linked list doesn't really work for us. We have to create a new class, okay? Let me call that my cursor, my book cursor. And then it's also going to take tuple of the string and the G. Okay, so now do and end. Let me leave this part a little bit later. Let me just explain to you in the architecture what does that really mean. Okay, it's the second solution. So now if you go back to the diagram over here, now what do we have? So we have the book over here. Let me just make it a little bit thicker. Let's say we have the book over here, and then it should be an descendants of a subclass of that, right? That's the inheritance we are having. Agree? That's a book. And now, what we should really have is we want to create a class, right? The class we're creating is basically like this. We have another class over here that is called my book cursor, which should be a subclass of the iteration cursor. Are we okay so far? Okay, so what does that mean? That means my book cursor over here should implement after, oh, maybe you should make it bigger. Should make it after, should really implement after, implement item, implement fourth. And now, what's the relationship between book and my iteration cursor? Inheritance or client supplier? Client supplier, I agree. If I try to draw that, story has to go across, but you can see that different color. Okay, it should be a client supplier, but what should be the label for the client supplier? Iteration cursor, oh, sorry, this one here. My book cursor over here, right, that's a return type. That's why it's a supplier. The label should be new cursor, right? Okay. But of course, okay, I'm just trying to condense the detail to you so you can be ready to implement for lab 3. Okay, so that means over here it should be new cursor. Okay, plus. That means that in the second solution, you have to create my book cursor yourself, which will inherit from iteration cursor and then implement after item and fourth. Okay? Start with this for lab 3, and then for Wednesday, I can give you a little bit more hints. Okay? We still have 5 minutes, which I really want to talk about something for you, for your lab 3, which could be a little bit tricky, right? Okay, let me just go there, and okay, we will talk about how you can use across on Wednesday. Let me just, we got 5 minutes, right, roughly? Okay, I'll do it quick, okay. So now, for your lab, for some syntax, which you will talk about when we talk about inheritance. Whenever you declare a type over here, let's say under local, object A, this is called a static type, static. Okay, and now what can you put over here under the curly brackets? Any subclass of the static type, okay? So this is called dynamic type. So for lab number 3, basically you were given some certain test cases which will have to, which enforce the clients, which enforce the parents and subclass relationship. That's something I want you to look at. But for the syntax, whenever you see under curly brackets, this is dynamic type, okay? This is equivalent to, in Java, A, over here, object A is new, and then question mark. Okay? Syntactically, they are equivalents. Well, the same idea, just organizing a different way in the syntax. Now, let me talk about this giant code over here, okay? Please, okay, I heard that. That's good. Okay. I'll do as much as I can. You know, if not, I'll definitely do it in the beginning of Wednesday, okay? I promise. Okay. So now, let me try to see what I can say over here. Basically, we have inheritance over here. We got sorted map ADT. We also got sorted model map. I would say study the way sorted model map is implemented very carefully. It will give you lots of inspiration about how the other 3 classes should be implemented, okay, in the student design cluster. Okay, now let's see. I'll give you some hints to study about. Okay, I want you to look at, first of all, you can see iterable over here, right? That's good. We just talked about it. I want you to look at this particular instance feature over here, okay? You can see instance is deferred, which means at the level of this particular superclass, instance is simply unimplemented. However, in the same class, in the submap feature, we are already using the instance over here. Isn't that strange? In the same class, we are referring to a deferred feature that will only be implemented later in the descending classes. You are actually allowed to do so, okay? This is something we're gonna revisit a little bit later after the reading week. It's called template design pattern. Which means at the level of this superclass over here, we simply say, even though we don't know exactly what instance can be, instance can be a sorted model map, it can be a binary search tree map, it can be a red-black tree map. We don't know yet. But at this point, all I know is, as long as I know the instance can be given, I can already use it in the context of some algorithm over here. That's how I calculate the submap. Okay? Now, go a little bit further over here. Now, if you look at the other class over here, sorted model map, which is a subclass of sorted map ADT. Okay? So now if you look at that class over here, I want you to see, is there any submap feature over here? No, right? Not only that it's not in the screenshot I'm making. If you look at the class for sorted model map, this is simply submap is not there. Which means this entire template over here is inherited to sorted model map verbatim. However, why would it work when we actually create an object of sorted map? Let's say we have sorted model map instance. If we simply say submap. Now, how is it going to execute a submap? That's a question. There's only one version for the submap feature, which is inherited from the sorted map ADT, right? However, this guy over here was simply deferred at the level of sorted map ADT. How would it work in this case? Can you see any hints from the sorted model map here? Can you see that? In this case, you can see that over here, instance is not deferred anymore. It's simply just implemented. Which means when we try to say sorted model map, that submap, it's going to basically follow this template over here, but whenever you encounter the instance, it's going to apply the instance definition over here in this particular class. Okay? Make sense somehow? Okay, yes, question, go ahead. Which one? The one that's cut off? I'll answer that. Okay, guys, anyway, that's what I want to say. So maybe on Wednesday, I'll try to say more to help you. Okay, I'll see you on Wednesday.